the Milky Way galaxy, circling a star called the Sun, is a small planet inhabited by intelligent life. Earthlings have always been curious creatures. Even as we discovered our own world, we dreamed of exploring others. Perhaps other beings inhabit planets around distant stars. If they're sending signals, we could detect them with this powerful radio telescope and maybe send a signal back across the cosmos. But might we ourselves leave our home on Earth to explore new worlds? We have already taken the first small steps outside our planet. We designed this shuttlecraft to carry people and cargo up into orbit. Here, far above the Earth's atmosphere, we're learning how to live and work in space.
Frank, you've got to go down over the orbiter.
Okay, student, nose sweep, going towards the starboard side.
The exterior shows just a little of the expected wear and tear of many trips back and forth. The shuttle is equipped with a robotic arm to move large payloads ferried up from Earth.
Houston, do we have a go for SPA's maneuver to release attitude?
It has lifted from the cargo bay a spacecraft which carries a German telescope named Orpheus and a remotely operated IMAX camera. Through its lens, we are seeing as never before the exterior of the shuttle as it orbits the Earth.
Discovery Houston, you have a go for SPA's release. Copy that.
Now, the Orpheus telescope has been released into orbit. We are riding with it, floating free in space. Beneath us, the shuttle pulls away, its cargo bay empty. Orpheus will spend several days observing the hottest and coldest gases in our galaxy. Then the shuttle will take it back to Earth. Over 3 decades, we've learned how to travel back and forth to space and live in low Earth orbit. Now that we've taken these first steps, are we ready to cross the great black void to explore the other worlds in our solar system? The journey will be hundreds of times farther than any we have ever undertaken. First, we need to understand how we adapt to weightlessness. Connected by tunnel to the crew cabin, a laboratory known as Space Lab is carried in the cargo bay on certain flights. Inside it, scientists are performing experiments developed by 13 different countries. two medical doctors, Norm Thagard and Roberta Bondar, a Canadian, are studying how our sensory systems behave when introduced to microgravity. More than half the astronauts experience space motion sickness the first day or two. German payload specialist Ulf Merbold is conducting an experiment to find out more about how it happens.
I've got Vection.
The subject sees one thing, but he feels another. His brain is confused by these conflicting messages, and he becomes disoriented. Is the spacecraft rotating, or are we? While Roberta spins, a tiny camera inside her helmet is recording the movements of her eye as it reacts to the motion. Data are collected at mid-flight, then again near its end. When the results are compared, it becomes clear that the more time people spend in space, the more they rely on the visual sense alone for orientation. But these results tell us only about how we adapt in the short term.
Spores 3 goes to centrifuge 204. Make sure it says spore 31G.
Spores, which one?
To find out how we're affected by longer stays, people must live continuously in a space station. There, we could learn how to maintain a closed life support system for months or years at a time.
One more. Interesting.
Recycling is a must. Future astronauts will be accomplished gardeners. They will tend small farms in space, like this hydroponic garden at the Kennedy Space Center that uses recycled water and oxygen to grow food. The plants must be kept free of contamination. Halfway to another planet, a crop failure would be a disaster.
180 reps, Lynn.
Keeping fit is another challenge. With no body weight to support, our muscles get weaker. Bones become brittle. The longer we stay, the worse the problems become.
Hey, Bobby, come on up here. We're going by Canada.
People traveling to other planets will spend years living in a very confined space. What kinds of emotional stress will we face? Will we get homesick, so far from everything we know? Isolated from family and friends and the familiar comforts of home?
There she is, John. Don't run into our home.
Our first journeys to another world were to our nearby moon.
Tranquility Base, Houston, you're cleared for takeoff.
But those round trips took barely a week. Today, on the Mir station, Russian cosmonauts live in space for many months. From time to time, new crews arrive from Earth in the Soyuz craft. Now, after almost a year in orbit, the cosmonauts will return home in Soyuz. And even though they've spent up to 6 hours exercising each day, when re-exposed to Earth's gravity, they are temporarily unable to stand up. Imagine arriving on an alien planet in this condition. But what if we could produce an artificial gravity as we travel to our destination? In 1968, Stanley Kubrick's classic film, 2001, A Space Odyssey, featured spaceship designs which would allow us to do this. As the ship spins around, anyone inside feels an outward or centrifugal force that acts like gravity. In another design, parts of the ship spin around a stationary hub. But the rotation of a small spacecraft could make the occupants disoriented or sick. We could avoid this if we built a spacecraft large enough and with a slower spin. But it would have to be about as long as the Golden Gate Bridge. How could we build such a large ship in space? To get to Mars, for instance, we might design a spacecraft with two modules, one attached to each end of a very long cable or tether. Once underway, the tether would be extended to separate the two modules. The whole assembly, rotating about once per minute, could provide the synthetic gravity needed. But until recently, tethers were merely an elegant idea. The concept would have to be tested.
So far, we have good satellite stability.
So an experiment was flown on the space shuttle. An Italian satellite was deployed on a very long tether. The crew was then to retrieve it.
Okay, let's do it like we simmed it. Warren, you're going to keep the tether under control, right? Okay.
At first, the tether behaved exactly as predicted.
What you don't want to do is yank on the satellite.
Right, you've got good tension, and the R dot is just oscillating a little bit, but it's basically zero.
Whoa, whoa, whoa.
Wait a minute, looks like
tether.
But then, the reel jammed, and the tether went slack.
Houston, we have slack tether. LDOT has stopped. The brake is
By
not on.
firing jets on both the orbiter and the satellite, the crew learned that they could tighten it once again, showing that we can control tethers in space.
Somebody needs to get ready
Tether's
with the
under
laser.
control. Turn on the other inlay.
Unexpected snags are bound to arise, but we learn from them and keep moving forward. To build more reliable spacecraft, we need light but tough materials. To test them, in 1984, we launched the satellite with dozens of materials attached to its surface, exposing them to the wear and tear of space.
Columbia, Houston, we have a tally-ho on LDEF.
We left it in orbit for 6 years, long enough for an interplanetary trip.
Ready to go get it?
Then the shuttle retrieved it and took it back to Earth.
Shadow effect. And this is some of the
We
debris
found a wealth of information embedded in these panels.
substrate that it's hit. Splatters.
As the microscopes reveal, the vacuum of space is anything but empty.
This pattern here, I don't know what this is.
A continuous bombardment of micrometeorites pitted the surfaces with craters. But the most serious hazard in space is radiation. As the shuttle hangs suspended above the Earth's horizon, we see only the lights of its cargo bay in the darkness. But we can't see the harmful cosmic radiation that is everywhere here. High-energy charged particles are streaming out from the sun and other stars. On Earth, we are protected by the atmosphere and the surrounding magnetic field. In space, the radiation can penetrate the walls of our craft. A Japanese X-ray satellite reveals vast clouds of radiation erupting from the sun. On interplanetary trips, we'll have to retreat to heavily shielded onboard shelters whenever solar storms are sighted. Most of the planets are too hostile for people to visit. But that doesn't stop us from exploring them.
Okay, understand. We have a go for deploy, so we're starting out. 5, 4, 3, 2, 1, mark.
We have motion.
Motion.
It's stable. It's clear of the SE.
Where humans cannot safely go, we send remotely controlled robot explorers. Commanding them from Earth, we use their electronic eyes and sensors to explore the alien landscape. In 1989, the Galileo spacecraft began a 5-year journey to Jupiter, the largest planet in our solar system.
Galileo just kind of dissolves out into nothingness as it goes into the darkness of space, and that's the last we saw of it.
Early images of Jupiter were sent back to Earth in 1979 by 2 robot probes named Voyager. This was our first opportunity to marvel at its great red spot, 3 times the size of Earth. The molecular building blocks for life may be swirling within Jupiter's turbulent atmosphere. If Galileo's probe confirms this, we should gain new insights into the origins of life. Though it is our nearest planetary neighbor, Venus was always a mystery. Thick cloud layers blocked our view of its surface. Then we sent a spacecraft named Magellan to orbit the planet. Its radar eyes could see through the clouds. Magellan collected so much data that we can now explore the surface as if we were actually there. We begin 60,000 feet up. To help scientists recognize its features, a computer has exaggerated the height of the terrain 10 times. Perhaps these pancake domes were caused by lava, pushing through weak spots in the surface. These craters, some the size of Connecticut, were made by collisions with comets and asteroids. On Earth, ancient craters like these have been eroded by wind and water. But there is little wind and no water here. Venus swelters beneath a thick atmosphere of carbon dioxide, which acts like a greenhouse. It allows sunlight to filter in, but then traps the heat inside. The surface temperature is hot enough to melt lead. In the distance, the great Gula Mons volcano. We are now soaring more than 250,000 feet above the surface. The long, smooth strips that now and then cross our path are small portions of the surface that Magellan's radar did not scan. The Magellan craft has shown us the fantastic surface of an alien planet where no human could ever hope to land. But there is another world in our solar system that people can visit. Future generations of explorers will walk upon Mars. To prepare the way for them, we could send a robot like this to scout a landing site. We might dispatch a whole flock of these helpers to explore the terrain. Unlike us, they are almost immune to radiation and need no air or water. And they never get homesick. Robots like this Russian Mars rover, being tested in Death Valley, California, have already been programmed for difficult tasks, like negotiating rugged terrain. More elaborate versions could help us construct a Mars base. But operating them will be a challenge. At the speed of light, a single command takes up to 20 minutes to travel from Earth to Mars. If there is or ever has been life somewhere else in the solar system, Mars is a good place to look for traces. A great rift valley splits open the Martian plain. It is as long as the entire United States. We're now descending from 40,000 feet into a part of the valley known as Candor Chasma. It is 5 times deeper than the Earth's Grand Canyon. The height of the terrain has not been exaggerated. This is how it really looks. Life as we know it must have liquid water to develop. Water may have flowed through these canyons long ago. Perhaps it nourished life. Fossil life forms may lie exposed on the floor of these canyons. If we find any, it would be our first proof that life has existed beyond Earth. It would mean that life probably is abundant in our galaxy and awaiting discovery in the universe beyond. Today, Mars is a frozen world. The average temperature here is lower than at the Earth's South Pole. But long ago, when water may have flowed here, it must have been warmer. We don't know why Mars turns so cold, but perhaps it could be made to change once again. Could future generations somehow transform Mars into an Earth-like world where people could live? To do it, we might imagine somehow raising the temperature to build up the atmosphere and melt the ice caps. This would create lakes and rivers. Then we could introduce plants to fill the air with oxygen. Animals and people could now breathe the air. A new world might be ready for us to colonize. What would life be like on Mars? Perhaps we could build farms and cities. Or perhaps we will leave Mars as we found it. Those decisions will be made by our descendants. If terraforming is even possible, it would take thousands of years. By then, we may have left our solar system to explore the stars beyond. Though it would take about 100,000 years to reach them with present technology, future generations may travel faster. For the present, we must use telescopes to explore the stars. Now, we are about to launch into space an instrument that will allow us to look to the farthest reaches of the universe and back in time almost to its birth. This is the Hubble Space Telescope.
Keep coming.
Once in orbit, above the shimmer of Earth's atmosphere, it will see 10 times farther than telescopes on the ground.
And down.
Astronauts Kathy Sullivan, Lauren Shriver, and Bruce McCandless have come here to the Lockheed Vehicle Assembly Facility for a final inspection.
That's the socket in the MLI that you put the preload tool in. Once you've got the door all the way open, and just crank it over center, so it's in its detailed state. Family and friends gather for the launch at the Kennedy Space Center. Among them is Dr. Lyman Spitzer, who first proposed the idea for a space telescope in 1946.
Well, this is a tremendous milestone today for me. Very exciting, very exciting. I suggested a telescope of this general nature would be very helpful to astronomy. And the idea finally took hold among astronomers and then among other people and finally even in Congress. And off it goes.
T-10, go for main engine start. We are go for main engine start.
Once Hubble is deployed, astronomers on the ground will be able to direct its eye to any region of the universe they wish to observe.
Give you a payload ID of 1.
Discovery would like you to go free drift.
While pilot Charlie Bolden on the left maintains the shuttle's precise position, astronomer Steve Hawley prepares to perform the deployment.
Discovery, go for Hubble release.
Hawley releases the telescope, then very slowly and carefully retracts the arm. The sky and sea of Earth reflected in its door, the Hubble Space Telescope, the creation of 10,000 people, is launched at last. It will remain here for many years, sending images back to Earth. Shuttle crews will visit Hubble on regular service calls to replace and upgrade its parts.
Yeah, looks good. I don't see any motion at all in here.
Story, I wish you guys had been here to see it because you'll never believe it. Well, superb is an understatement. Residuals were 0.02 and 0.0.
The telescope would reveal objects in detail never before seen. But there was a problem. A flaw was found in the shape of the telescope's primary mirror. A repair would be necessary. As part of the regular service call, another crew would make the repairs 3 years later.
Endeavor, you've got to go for capture.
First, the crew would have to recapture the telescope.
Endeavor, the right-hand solar array, as we can see it, is one side of it is bent way over. So clearly we have a dynamic situation.
There's a problem with one of the solar panels that provide electrical power to the telescope.
Looks like the outer bi-stem has the kink in it, and it's twisted 90 plus degrees clockwise there at the kink.
Once the telescope is secured in the cargo bay, the astronauts will move outside for a closer inspection. So begins the most ambitious and difficult service mission ever attempted. Payload Commander Story Musgrave and astronomer Jeff Hoffman are both veteran spacewalkers.
Story, for some reason, is not built like the rest of us. Most of us just float up to the hut, and Story has to screw himself in.
If you're a person that gets claustrophobia, this is not the kind of business you want to get into.
They'll depressurize here in the airlock, then go to work. It had been planned that the crew replace the solar panels as part of the regular service. But now, the twisted panel cannot be safely stowed in the cargo bay. They have no choice but to throw it overboard. Mission specialist Kathy Thornton will do it.
Okay, they say you gotta go for release. Hey, no hands.
Such a large object floating in space can pose a hazard to other spacecraft. So bursts from the shuttle jets are fired directly at the solar panel to make it spin. The motion will speed up its descent to the Earth's atmosphere, where it will burn up.
There it goes. Looks like a bird, Tom. Look at it. That's quite a sight.
Now, work on the telescope can resume.
Okay, KT. Coming straight on up. Looking real good. I'm gonna let go. Hey, God, take me away. Just come right up easy, just like you're going. Okay, bring the forward up a little more.
It's difficult to maneuver bodies and equipment unassisted.
Hey, Clyde, let's drive toward the telescope.
The repair of the telescope would be almost impossible without the help of the shuttle's arm.
Where's the cake?
It is controlled from inside by Swiss astronaut Claude Nicollier, while Ken Bowersox, the pilot, acts as lookout.
Keep coming up, Claude. Stop. Stop.
Brakes on.
Not even pulling it, I'm just coaxing it with my fingertips.
The new wide-field planetary camera will tell us more about the size of the universe and how rapidly it is expanding.
Okay, here we come.
The crew lifts it up with great care. The tiniest bump could damage its delicate parts. The astronaut teams alternate each day, spending up to 6 hours in the cold vacuum outside.
Okay, I'm gonna slip over. You got another foot to keep coming up. Keep coming up. Coming up. Coming up.
All of their tools must be tethered to the workstation to keep them from floating off into space.
Endeavor Houston for Story. You gotta go to open the doors.
Okay, swing it.
After 5 days of intensive work and many dazzling accomplishments, the astronauts are now ready to install the critical corrective optics package. It's a kind of contact lens designed to bring Hubble's giant eye into focus.
Pitch up a little.
If it succeeds, we will be able to look back to the edge of time.
Good work, guys.
The service and repair are now complete. The mission drew upon every skill we have learned throughout 3 decades of work in space. Whether repairing a telescope, assembling a space station, or building a base on a distant planet, we must rely upon the teamwork of humans and machines if we are to succeed in this challenging new environment away from Earth.
Endeavor, you gotta go for release.
The Cape of Good Hope beneath it,
the Space Telescope is now poised to begin a new era of exploration. One of the astonishing discoveries is a first close look at an enormous and very unstable star we call Eta Carinae, 4 million times more luminous than our Sun. Its last outburst was seen in 1841, and now Hubble reveals that it has blown 2 massive clouds into space. The clouds contain the heavy elements essential for the creation of life. Now, in the heart of the Orion Nebula, Hubble reveals a stellar nursery. Gas and dust are condensing here to create new stars. And even more astounding, new planets are being born. Never before seen, the dark material appears to be a new solar system forming around a young sun. Hubble has now provided evidence that planets are common in the universe. Life may be widespread among them. Perhaps we will hear a signal. Our curiosity and our need to progress compel us to move outward, to explore the worlds of our solar system, our galaxy, and the universe beyond. The distances are vast, the voyage hazardous, the destination daunting. Still, we choose to explore. What we discover will shape our destiny in space.